Welcome back, students. We will be looking at section 2.2, terminology for the multiplication property of equality. So remember 2.1 was dealing with the addition property of equality. Now it's going to be the multiplication property of equality. We're still going to be thinking about keeping our scales balanced. If we do something on one side, we're going to do the same thing on the other side. So that doesn't change. All right, so let's look at A equals B. So remember, A equals B, B equals A, okay? They are the same value. So then we would put in our first blank. If basically we multiply A by C, we would need to multiply B by C to keep our problem balanced. Or if we divide A by C, we would need to also divide B by C to keep it balanced. All right, so multiplication property of equality. If you multiply on one side of the equation, then you must multiply on the other side of the equal sign. If you divide on one side of the equation, then you must divide on the other side of the equal sign. All right, so let's look at some examples. 5 equals 5. If I multiply 5 times 10 on one side, to keep our equation equal, I need to multiply 5 by 10 on the right side as well. And we end up with 50 equals 50. 5 equals 5. If I multiply it by a -2, I need to multiply the other side by a -2. And that would give us -10 equals -10. 8x equals 8x. If I multiply 8x by 2 on the left, I need to multiply it by 2 on the right, so that we end up with 16x equals 16x. So again, if I do this on one side, I need to make sure I do it on the other. -8x. If I multiply -8x by a negative, then I need to multiply -8x by a negative on the other side. And that would give us a positive 8x equals a positive 8x. All right, so let's look at these fraction examples here. I have 1/3 x equals 1/3 x. If I multiply 1/3 x by the reciprocal, by 3/1, I end up with 3/3x. And 3/3 reduces to 1. If I do that on one side, I need to make sure I do it on the other side. So you'll notice on this side, I did the same thing. I multiplied it by 3/1. I got 3/3, ended up with 1x. 1x equals 1x. X equals x, okay? The 1 is just understood to be there. We don't actually have to write it. But just for the sake of the example for you, I have it in there. Let's look at one more. If I have -4/5 x equals -4/5 x, to cancel them out, I need to multiply by its reciprocal. So again, I multiplied by the reciprocal, so -5/4, and I multiplied by -5/4 on this side as well. That gives me a 20/20 and a 20/20, and that reduces to 1x equals 1x. Good. All right. So let's look at two good examples, okay? So example 1 is on the left here. We'll scroll back up and look at the right side in just a minute. Let's see if I can fit all of that on the screen. Okay, so we start out with 2x plus 5 equals 9. We learned in the last lesson that if we want to deal with that 5, we need to subtract it from both sides to cancel it out. That gives us 2x plus 0 equals 4. We're doing well. We've subtracted 5 from both sides, so we're still balanced. We're still equal on each side. But what I'm left with is 2x equals 4. This is where the multiplication property of equality comes in. To get that x by itself, I need to divide both sides by 2. The reason I picked 2 is because the 2 is with the x. So I'm going to divide 2 by 2 right here. And if I do that on one side, I need to divide the 4 by 2 as well on the other side. So 2 divided by 2 gives us a 1. And then 4 divided by 2 gives us a 2. So our answer is going to be x equals 2. But let's check our work just to make sure. So I plugged the 2, my value of 2, in for where that x was, because the x is its disguise. So now I have 2 times 2 plus 5 equals 9. Well, 2 times 2 is 4. And 4 plus 5 is 9. So we did, in fact, solve and get a true value for x. X is equal to 2. Now let's look at our second example. We have 1/3 x plus 5 equals 9. To deal with the 5, we're still going to subtract it from both sides. So whenever you have a digit, a number by itself, what you're going to do is either add or subtract it, depending on if it's positive or negative. Then we have 1/3 x plus 0 equals 4, which just simplifies down to 1/3 x equals 4. Now the difference between what we just did and what we're about to do is that we actually have a number right next to the x. They're being multiplied. This is multiplication basically, which is different from this right here. So when you have this situation, we need to multiply by the reciprocal. So I'm going to multiply 1/3 x by 3/1. If I do that on one side, I need to do that on the other side. So I end up with 3/3x equals 12/1. 3/3 reduces to just 1x, and 12/1 reduces to 12. So our answer is x equals 12. Let's check that. So I plugged in the 12 for my x right here. I'm going to make this a fraction. So 12 times 1 is 12, and then 3 times 1 is 3. So we end up with that here. So now I've got 12 divided by 3 gives me 4. 4 plus 5 is 9, and 9 equals 9. So we have, in fact, solved this problem correctly. As I said earlier, we'll have multiple practice problems to go through these steps just to make sure you have plenty of practice and examples to look back at as you're learning this. All right, so let's look at our quote. There is geometry in the humming of the strings. There is music in the spacing of the spheres, by Pythagoras. All right, guys, hope you're having a great day. I'll see you in the next video. Bye.